All right, I want to start out with just a brief review of what we did in the previous lesson, which was using our triangles in a unit circle to find sine, cosine, and tangent of various angles. So I'm just going to do two additional problems here just to kind of review that. You had the homework key, but just to hear it explained one more time. So we're going to find sine, cosine, and tangent for the given angles. So let's say that our theta is 450 degrees. This is actually try these part B on page 496 if you'd like to put it in there. So remember that the steps that we talked about, the first thing that you always have to do is to sketch the angle. So I need to sketch 450 degrees. So if I draw my axes, and 450 degrees, obviously bigger than 360, so it's more than a full rotation. So 360 degrees would land here. So I have to go 90 more degrees than that because 450 minus 360 is 90. So 90 more degrees hits right here. So remember, this is what we had done several lessons ago with the quadrantal angles. Here, I actually don't have to draw the triangle, and this is why I wanted to pick this one to remind you that yes, in the last lesson we did the triangles, but not everything is a triangle because we had done the quadrantals previously. So the ordered pair here, because I didn't go any left or right, means the x-coordinate's 0, and because I'm in a unit circle, the radius is 1, so the y-coordinate of this point on a unit circle would be 0, 1. So that means that when I go to find my values, again, cosine is the x-coordinate, so I can simply write out cosine of 450 degrees equals 0. And then sine of 450 degrees equals 1, because that's the y-coordinate. Now, what we had said in the last lesson, one of the things that we filled out actually on this the back of this worksheet down here, we had written that the tangent of the angle is y over x or sine of the angle over cosine of the angle. So that's what we're going to be using here. I can go back. There we go. So tangent of 450 degrees I would get by taking the y-coordinate or the sine divided by the cosine. So in this case I would do this. I would do 1 over 0, but keep in mind that dividing by 0 is a big no-no. You learned that in like 4th grade or something, that you can't have 0 in the denominator of a fraction. So that means that the tangent of 450 is actually undefined. And that would be our answer there. So these would be our 3 answers. If it were 0 over 1, that would be 0. 0 divided by 1 is 0. If you tried to do it in your calculator, it'll tell you so. If you try to do 1 divided by 0, it'll tell you error. So that is undefined. Okay, so I should have probably labeled this B since this is try these B. Then I also want to look at try these C, which is where theta is 2 pi over 3. So sketching the angle is, again, our first step. So I'm going to sketch 2 pi over 3, which that's 2/3 pi. So I know that pi lands here. So I'm going 2/3 of the way to that, which would be this. So this is 2 pi over 3, the angle, 2/3 pi. Next step is always to then label the reference angle. So in this case, my reference angle is here, it represents, and I drew it a little too far as its looks, but that's okay. It's going to be 1/3 pi because I went 2/3 of the way. I have 1/3 left. So 1/3 pi is the same as 60 degrees. So it doesn't matter which way you label it because it's not the answer. If we'd asked for a reference angle as an answer, we would of course write it in radians. Once you do that, we draw the triangle. Remember, we use the x-axis, not the y-axis. So x-axis, I'm going to connect the terminal side to it. Here is where my triangle should go. This is the point whose ordered pairs I'm trying to find. So when we draw the triangle, then we label the triangle with our 30, 60, 90, 45, 45, 90 values that, again, these are the ones that you should have in your notes. If you weren't here, you'll have to copy them from someone, but the ones that we did in this area here. Okay, so we know that the radius is always 1 because we're in a unit circle, so that means the hypotenuse is 1. Across, and again, it's not drawn to scale. I did a pretty bad job there, but the 60-degree angle is the long leg. The 30-degree angle is the short leg. So that means that this guy would be 1/2, and this guy would be radical 3/2. Remember that we always label the triangle with positive values. It's okay with me if you want to label them with negatives. But when you write the ordered pair, that's where you have to think about the ASTC that we did on the homework. Because since I'm in quadrant 2, that means to get here to this point, I went left 1/2. So that's a negative value. Then I went up, that's a positive value, so radical 3/2 here. Okay, so this is my ordered pair, which means we have labeled the triangle and the ordered pair. Then we should be able to get all of our values. So the cosine of 2 pi over 3 is going to be negative 1/2. The sine of 2 pi over 3 is going to be positive radical 3/2. And then again, we get the tangent by doing the sine value divided by the cosine value. So radical 3/2 divided by negative 1/2. Remember that when we divide fractions, we're really multiplying by the reciprocal. So the reciprocal of negative 1/2 is negative 2/1. So these can cross reduce, and I end up with negative radical 3. And that is my tangent. Here is my sine. Here is my cosine. And then I'm done. Okay, so I wanted to review that using the triangle for the main reason of that what we're going to do today is kind of an alternative to actually having to draw the triangles. But it's very important to understand the triangles. There will be some things, you know, in pre-calc where you definitely have to draw the triangles. So this is not just something that we should now just forget because we have an alternative way. Okay, so now what we're going to do, the next thing is, again, you should, if you've been here and you've been taking the notes, have this side of the handout completely filled out already. What we're going to do now is we're going to look at this side, which is really just radian counting. So in a unit circle, we are going to count by multiples of pi over 4. Hopefully we remember that this is on our memorized list, that pi over 4 is the same as 45 degrees. So we're counting by 45 degrees essentially, which is why my first mark is here, halfway to 90. So if this is 0 radians where I'm starting, then this one is pi over 4. This is going to be 2 pi over 4. This is 3 pi over 4. And then we just continue. This is 4 pi over 4 because we're counting by fourths. 1/4, 2/4, 3/4, 4/4. Here's 5/4, 6/4, 7/4. And then when we get back around to where we started, that would be 8/4. So this is just counting. We keep the denominator the same, we keep the pi the same. Other than that, it's counting. 1, 2, 3, 4, 5, 6, 7, 8. Now we're going to reduce all of our fractions. Don't do anything with the pi. Leave it in the numerator. So, of course, 0 is our starting point. That stays. Pi over 4 doesn't reduce. 2 pi over 4 does. That reduces to pi over 2. 3/4 does not reduce, so it stays. 4/4 is 1, so 1 pi is just pi. 5/4 does not reduce. 6/4, they're both divisible by 2, so 3 pi over 2. 7 pi over 4 does not reduce, and 8 pi over 4 is the same as 2 pi. So notice, now you should recognize some of these as on our memorized list. Pi over 4 was on there, pi over 2 was on there, pi was on there, 3 pi over 2 was on there, 2 pi was on there. So all of these things that we've done are now going to be coming all together. So this is, these are some of our radian measures that are going to go on our unit circle. Now we're going to do the exact same thing, only instead of dividing pi into 4 pieces, because see, this is pi, so we divided that line into 4 pieces. Now we're going to divide it into 6 pieces. So here's pi. You can see I've got 1, 2, 3, 4, 5, 6 pieces here. So these are multiples of pi over 6, and we're going to do the exact same thing. So I'm going to start at 0. This is 1 pi over 6, 2 pi over 6, 3 pi over 6. We're just counting. Hopefully we're good at that by now. So 5 pi over 6 here, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, and when we get back to where we started, we have 12 pi over 6. Notice that in the middle, you can see where the marks for the 45 multiples were, the multiples of pi over 4. Now we do the same thing that we did up here. We're just going to reduce the fractions. So 0 stays the same, pi over 6 stays. 2 and 6 are both divisible by 2, so this becomes pi over 3. 3 and 6 both divisible by 3, that's pi over 2, which should make sense. It's a repeat from what we have up here, so it should be the same thing. 4 pi over 6 divided by 2 is 2 pi over 3. 5 pi over 6 does not reduce. 6 pi over 6 is pi, which we should know because that's 180. 7 pi over 6 doesn't reduce. 8 pi over 6 does. They're both even, so they're both divisible by 2, so 4 pi over 3. 9 pi over 6, they're both divisible by 3, so 3 pi over 2, which again is a repeat from up here. 10 pi over 6, both divisible by 2, so that's 5 pi over 3. 11 pi over 6 doesn't reduce. 12 pi over 6 reduces to 2 pi, which we should already know. So the reason why I do this is because I want you to see that these values that are on the unit circle are not arbitrary. All we're doing here is dividing it into our multiples of pi over 6 and multiples of pi over 4. The reason why we choose these multiples is because pi over 6 is 30 degrees. So the multiples of pi over 6 either have a 30-degree reference angle, like this has a 30-degree reference angle, this does, this does, this does, or the other ones have a 60-degree reference angle, here, 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 and here. The ones above all have a 45-degree reference angle. So what these are if we were drawing the triangles, these are all the places that we could land where we would be drawing either a 30, 60, 90 triangle or a 45, 45, 90 triangle with the x-axis. So this is combining with what we did in the last lesson. So this worksheet should now be completely filled out in your notes. And so now get out the blank unit circle that was passed out to you. So let me get mine out here. Zoom in. It's tricky here because we got to get the whole thing in the same screen. Okay, so the only thing that cuts off is the positive negative, which is fine because I can just write it out to the side. There, I was able to resize it slightly, so now I've got everything on there. So what we are going to do today is we are going to fill in the entire unit circle. This you do not have to have memorized. I've already said this, but if you weren't in class that day for some reason and didn't hear me say it, you will be provided with a unit circle. But it does no good to have a unit circle in front of you if you don't know where everything is coming from. So what we are going to do is we're going to fill out the entire thing here. So I'm going to get my blue pen here, and we're going to fill in all the degree measurements. So we start at 0 degrees. The first mark is 30 degrees. Second mark is 45. And last mark is 60. I guess I didn't need to write the degrees there because it's already there. So this should make sense. Look how the 45 is closer to the 30 and the 60 than the 30 and the 60 are from the axes. So these are spaced evenly, and these are all the spots where if I were to go and drop the perpendicular from the intersection point, I would have a triangle that is either 30, 60, 90 or 45, 45, 90. The only other places on the unit circle that I have are the quadrantals, which 90 degrees is our first. So then this is 30 degrees past 90, so 120. This one's 135, 150, 180. 30 degrees past 180 is 210. 15 degrees more than that is 225. Then 240. Our quadrantal here is 270. 30 more degrees is 300. Then 315. Then 330. And then finally, when we've made a full rotation, we get to 360 degrees. Okay, now we're going to go in and do the radian measures. So 0 radians is where we start. And I'm going to do just like what I just did on the counting. I'm going to go through and I'm going to do all my multiples of 45 first because those are my pi over 4s. And then I'm going to go back and fill in all the other ones with pi over 6. So this is 1 pi over 4. This is 2 pi over 4, which is pi over 2. 3 pi over 4. 4 pi over 4, which is just pi. 5 pi over 4. 6 pi over 4, which reduces to 3 pi over 2. And then 7 pi over 4. And finally 8 pi over 4, which is 2 pi. So these are all either a quadrantal or a place where I would be drawing a 45, 45, 90 triangle. Okay, so next I'm going to go in and do the multiples of pi over 6. Now remember, all the quadrantals are going to be multiples of those two, even though they're already filled in. So if I do pi over 6, which is 30 degrees, then this is 2 pi over 6, which is pi over 3, which is on our memorized list. This is 3 pi over 6, which is pi over 2. This is 4 pi over 6, which reduces to 2 pi over 3. So then 5 pi over 6 would be here. 6 pi over 6. 7 pi over 6 does not reduce. 8 pi over 6 is 4 pi over 3. 9 pi over 6 already filled in. 10 pi over 6 reduces to 5 pi over 3. 11 pi over 6 here, and then 12 pi over 6 is already there. Now, if you take a look at this, let's see, which one is it? Not that one. This one. This part of your handout, you would see that we've already filled in the ordered pairs for the 30, the 45, and the 60. So we're just going back and we're rewriting those. We don't have to draw the triangles over, but my 30-degree angle, my cosine, and here I'll use a different color, was radical 3 over 2. My sine was 1/2. On 45, I had radical 2 over 2 for both of them. My 60-degree was just the reverse of my 30-degree, so 1/2 was the x-coordinate or the cosine, radical 3 over 2 was the sine. My quadrantals I should also have filled out on that worksheet. This one is 1, 0, 0, 1, negative 1, 0, 0, negative 1. Now, we could go in and draw all the triangles if we wanted to fill in all these values, but we don't need to, because this 150-degree angle, for instance, if I drop the perpendicular here to draw the triangle, its reference angle is 30 degrees, which means because I'm in the unit circle, the hypotenuse is 1, the short leg is 1/2, the long leg is radical 3 over 2. So I could do all this if I wanted to, but it's the same triangle that I would draw over here at 30 degrees. It's just that it's in quadrant 2. The only thing that changes in quadrant 2 from quadrant 1 is that I went to the left instead of to the right, which means it's going to have the same coordinates as this, except since I went left, it's going to be a negative x value. The y value is the same. So quadrant 2, I can copy the values from quadrant 1, except make my x's negative. So the middle one is a 45-degree reference angle, so it should be the same as the 45 value, except that the x is negative. This one, it's a pi over 3 or a 60-degree reference angle. It should match the pi over 3 here, except the x is negative, so negative 1/2, positive radical 3 over 2. Notice that if you fold this hot dog style, they should line up on their counterparts. So this angle lines up on top of this angle, this one on top of this one, the ones that they match. Now, we can also fold this hamburger style, and we have a line up here too. But now I'm going down into quadrant 3. And in quadrant 3, if I'm drawing the triangle, I have gone to the left, which means my x is negative, but I've also gone down, which means the y is also negative. So this is the 30-degree reference angle because it's got a denominator of 6, denominator of 6, denominator of 6. So I'm going to copy this guy or this guy, but they're both negative. So negative radical 3 over 2 for the x, negative 1/2 for the y. This next one is pi over 4, denominator of 4, denominator of 4. These match. So negative radical 2 over 2 for both coordinates here. The pi over 3 one should match the pi over 3 in this quadrant. So these coordinates, except both negative. And then finally in quadrant 4, if I'm drawing the triangle, I went to the right and then down. So my x values are positive, but my y values are negative. So again, match the denominators. This has a denominator of 6. It goes with this one. So the x is positive and matches this one. The y matches this except negative. And then we go from there. This one should go here. So radical 2 over 2, negative radical 2 over 2. Down here, 3 denominator, 3 denominator. So 1/2, negative radical 3 over 2. Now, the positive, negative, here, the ones that we've discussed so far, this goes with our, and I'll just write it down here, our ASTC. So right now, we know that they are all positive in quadrant 1. None of them are negative. In quadrant 2, we know that the sine is positive, which means that the cosine and the tangent are both negative. In quadrant 3, we know that the tangent is positive, which means that the sine and cosine are both negative. In quadrant 4, cosine is positive, so sine and tangent are both negative. And this is the unit circle. So we've spent a lot of time explaining it because it's so important that you understand what it is we are doing and why this works. Why do we have the unit circle? So now we're going to talk about why we have the unit circle. So if you turn to page 497 in your Springboard book, the bottom of 497, you'll see that number 4 in there was filling in the unit circle, but it's super tiny in there, so I gave you a bigger one to fill out there. So number 5 at the bottom of the page asks you to use the coordinates from item 4 to find the sine, cosine, and tangent of 210 degrees. Now, this problem could absolutely be done the same way we did up here, by drawing the triangle, labeling the sides, finding the ordered pair, and going from there. But now that we have the unit circle, we don't need to. If I find 210 degrees on my unit circle, so here's 210, here's the ordered pair already written out for me. So now all I have to do with sine, cosine, and tangent is list them from the ordered pair. Now the ordered pair is not the answer. I am going to list the ordered pair because that helps me to find my answer, but the ordered pair is not the answer itself. So this is my ordered pair, which means for my answer, I would say cosine of 210 equals negative radical 3 over 2. Sine of 210 equals negative 1/2. And then tangent is the only one we need to do work for. You better have work in your homework if you want me to stamp your paper. It's going to be sine divided by cosine. And it's fine with me if you skip this step and go straight to multiplication by the reciprocal. Here, these are going to cross reduce. So I've got negative 1 times 1 here, which is negative 1. On the bottom, I've got 1 times negative radical 3, which is negative radical 3. So positive 1 over radical 3, which needs rationalized. And so I get radical 3 over 3 for my tangent. Already had my sine and my cosine. So that's what we'd be doing there. Number 6 would be the exact same thing as what I just did in number 5. Except that it's given to you in radians. So if we do the same thing there for number 6, it's asking us for sine, cosine, and tangent of 5 pi over 4. So 5 pi over 4, if we look at our unit circle, lands right here. So I've got negative radical 2 over 2, negative radical 2 over 2. So that means that my cosine of 5 pi over 4 is going to be negative radical 2 over 2. My sine of 5 pi over 4 is going to be negative radical 2 over 2. My tangent of 5 pi over 4 is going to be the sine divided by the cosine, so negative radical 2 over 2 divided by negative radical 2 over 2. Now, this one I wrote it this way so that you could see it if you didn't already realize. You're dividing two things that are the same. So if you want to do the whole multiply by the reciprocal thing, you can. You should still get the same answer. But when you divide two things that are the same, hopefully you know that the answer is 1. So that can save you a little bit of work there. Okay, I want you to add an extra example in the margin just because here the book doesn't really give you any that aren't landing exactly on the unit circle, which does you a great disservice here. So one thing that I would like to do is to do a problem where it doesn't land there. So an extra example. Let's say, and on your worksheet, it's not going to ask you for all 3 things. It's going to ask you for one of them. So let's just say that I am going to ask you for the tangent of negative 17 pi over 6. And this is a problem on your worksheet, let's say. So what you're going to do first is you have to find where it lands. And this is not something on the actual unit circle, unlike these examples from the book. So that means that I am going to have to do just a little bit of work first to find where it lands. Let me be very clear. It should land on a spot that's on the unit circle. If it doesn't, you haven't found it correctly. So if I want to sketch negative 17 pi over 6, it may be helpful to write it as a mixed fraction. So 6 goes into 17 twice with 2 left, or with 5 left over. So this is the same as negative 2 and 5/6 pi. So if I'm graphing it, negative 2 pi is a full rotation. That takes me here. 5/6 is almost an entire additional pi. So it lands right here. And again, use your head here. The denominator is 6. That means that my reference angle, what's left, has to have a denominator of 6 also. So this lands in the place in quadrant 3 that has a denominator of 6 because my reference angle is pi over 6. So I then look on my unit circle to find the angle that lands there, which is going to be this angle right here. It's the one with a denominator of 6. So this is my ordered pair, the same place as where 210 landed. So that means if I'm looking for the tangent, I'm just going to take the y value or the sine value divided by the x value or the cosine. So negative 1/2 divided by negative radical 3 over 2 which gives me, again, once you see this, many people, know that what answer they're going to get. So it's okay with me if you don't write out the rationalization here once you've seen it a few times, because you're going to keep getting the same repetitive answers. Always double check after you've found your answer to make sure that it makes sense with your ASTC. So in quadrant 3, which is where I landed, tangent is positive, which my answer is. So I know that that makes sense. Okay, so questions just like this are what you're going to be doing in your homework. Use your unit circle that we just filled out. You can draw the triangles if you want. You don't need to draw the triangles. I would suggest drawing sketches for ones that aren't actually found on the unit circle itself. And that's it for this lesson.